We founded this institute 24 years ago, 1999, from scratch, and we had a rented house till last year. And this building is not officially inaugurated yet. On 8th of December 2023, this year, for about 1.5 months, this building will be inaugurated. That is where we will start our silver jubilee year.
Thank you very much. What I'd like to do today is to tell you a little bit about some of my space efforts. Can you hear okay?
Yes. Yes, we can.
Make it full screen.
Yes, we can hear you. We can hear you okay. Please go ahead.
All right, and can you see my
Yes.
presentation?
Yes.
All right.
Yes.
Okay, so I want to tell you a little bit about two telescopes, the Hubble Space Telescope and the James Webb Space Telescope. But first I would like to congratulate India for the successful landing on the moon of Chandrayaan-3. It was very spectacular. And the collaboration between India and the United States in a mission that I helped start when I was working at NASA headquarters that will launch early next year, which will also be very spectacular. Something that will tell us a great deal about the health of our forests, about earthquakes, ice melting in Hindu Kush, Himalaya, and even sea level rise. And that's the NASA Geosynthetic Aperture Radar. When it comes to NASA and space science, I think of it in 4 terms. The mission: to innovate, create new tools, new scientific instruments, to be able to explore the cosmos. And when we explore the cosmos, whether it's our solar system, or the stars, our galaxy, the universe, our sun, or the Earth, we discover things. And as human beings, when we discover things, it gives us great pleasure, it gives us important information, but also it allows us to inspire the world. Space science at NASA is very lucky because we get to ask very big scientific questions. Where did we come from? And where did the universe come from? Where did the chemical elements that we're made out of come from? Where did the solar system come from? How did the Earth form? How did life start on Earth? Where are we going? What's the future history of our universe? Dark energy tells us that our universe is accelerating its expansion. What's the future trajectory of the climate of planet Earth? And where as humans are we going? And we hope we're going onto the moon, to Mars, and even further. And then the final question is, are we alone in the universe? This is actually a very well-posed scientific question. We know there's life on Earth. We have some idea of how it may have started and evolved. And we know that there are the images of stars are very, very precise and steady. They don't twinkle. And that allows us to take images that are much clearer than we could ever take on Earth. The Hubble Space Telescope was launched in 1990. Originally, the mirror was determined to be almost perfect, but in astronomy, almost perfect is not enough. It had spherical aberration that caused images to be fuzzy. Fortunately, the Hubble Space Telescope was designed to be serviced, upgraded, fix broken bits by the space shuttle. And so we did 5 missions to upgrade and repair the Hubble Space Telescope, starting with the mission in 1993, put in some corrective optics, kind of like contact lenses or glasses, which helped to improve the imaging of Hubble. And ever since then, it's been just spectacular. One in 1999, in which we put on new solar arrays. We put on some a new computer, gyroscopes, and a few other instruments. 2002, when we put in the advanced camera for surveys, new solar arrays, a cooling system for the near-infrared camera, and repaired the power system. And then finally in 2009, where we did complete maintenance of the whole telescope, so that even now, in 2023, 14 years later, the telescope is still operating perfectly. Point to end.
It has come only the first thing is the esteem. So, probably you have chosen the screen, yes, now it's changing, thanks.
Okay. Okay, so let me try something slightly different.
It is working now. It changed, the slide has changed.
Explore, discover, and inspire. These are the big questions. That's Edwin Hubble. Let me know when you see Edwin. The Hubble Space Telescope. This is the slide that shows all of the Hubble missions. And do you see that? Okay, the crew. Okay, now let me know if you see the movie, okay? Once we get out to the launch pad, we crawl into the vehicle, and everybody else tries to get 5 kilometers away or more. So once everybody is clear, we light our rocket liquid engines, main engines, then the solid rocket motors. And at this point, it's a very violent ride. For the first 2 minutes, we run on all of the engines. And after the solid rocket motors run out, they come off, and the liquid hydrogen liquid oxygen engine continues till 8.5 minutes after launch. We're in orbit, going 17,500 miles an hour. We get rid of that large tank, which was the liquid hydrogen liquid oxygen tank, open the payload bay doors of the shuttle, and inside is all of our gear for doing the spacewalks. So it has doors, and you open those doors, and there are 2 cameras. This is actually the old corrective optics from the Hubble. We took that out, and we installed a cosmic origin spectrograph, an ultraviolet spectrograph in its place. Now, the advanced camera for surveys had an electronics problem, and so it was not able to occur. And in order to fix it, we had to take out tiny screws and pull out circuit boards, which is something that had never been done in space before. And of course, how do you take out tiny screws in space? Well, with a tiny screwdriver. But we didn't want to lose any of the screws, so we used this funny contraption that captured all the screws so that they wouldn't float away. You can see them floating there. Next, we pulled out the circuit cards. And put in new circuit cards so that we could repair the instrument. This was a particularly difficult task. It had never been done before. And so we practiced over and over and over again here on Earth so that everything would go hopefully as planned. So here we are over the surface of the Earth. That's the Baja Peninsula of Mexico, traveling 7 kilometers per second. And fortunately, the repairs all went well. That's Mike Massimino. And so coming in after a very long day, you can see I have a big smile on my face. That camera, the advanced camera for surveys, is the one that Adam Rees, Paul Perlmutter, and Ryan Schmidt used to win the 2011 Nobel Prize in Physics for the discovery of dark energy. And their discovery was the accelerating universe, which is interpreted to be due to dark energy, which we know nothing about. Maybe Sandeep Chakrabarty knows something about it, but most people do not. 21 degrees nose down. At 100 meters, we put the landing gear down, and then land on the runway that's about 4,000 meters long at Edwards Air Force Base in California. We put on a parachute so the nose gear doesn't quite slip apart, and then use the brakes to slow it down. So this is the Great Nebula in Orion, which is a constellation in the sky that has 3 stars with a belt and a sword, and the middle star in the sword is actually a star-forming region. And one of the reasons I like this image is because it is a very familiar asterism, star pattern in the sky that we can see in winter in North America. But also because this is a place where baby stars are born. This is what the Earth and our solar system looked like just a few 50, 100 million years after its formation. We were in one of these cocoons of gas and dust from which our sun formed. Now, all of that gas and dust has since been blown away, but in the Orion Nebula and many others, we can see the process of baby stars, stellar formation occurring. NASA, during Project Apollo, we were preparing to go to the moon. And people remember him because he led that Apollo mission. But what most people don't know is that in those very early years of NASA, in the 1960s, he is the director who made sure that science, an integral part, space science, was an integral part of NASA. And as a result, we named the James Webb Space Telescope after him. The James Webb Space Telescope is designed to do things that the Hubble Space Telescope cannot do. The Hubble Space Telescope sees light in the same colors that we see with our own eyes. Basically, we call it visible light. And the James Webb Space Telescope sees infrared light. With a sun shield, block the sun from the mirror. That's about the size of a tennis court. And it has 5 layers of something called mylar insulation. And that protects it from the sun, like sunscreen. It blocks the sun. Then the mirrors, after the sun shield was fully deployed, then the secondary mirror will deploy. There it is. And then the wings of the mirror will deploy. And then the telescope had to cool from basically the temperature of the Earth all the way down to 40 Kelvin. Its component colors from objects, we can learn about what they're made of. Nebula. And these images are just the very beginning of what we're able to see with James Webb and even with the Hubble Space Telescope. There's still very much more that both telescopes will do. So with that, I would say that all of the images that I've shown you from Hubble and James Webb are available online. I think it's great that India has put its AstroSat data online and is dedicated to putting all of its data online, so scientists around the world can use it. And we have the same policy in the United States to try and put all of our data online. These are the two websites that you can see those images. So with that, my slideshow. And if you have a couple of questions, we'll be happy to answer.
Yeah, John, thank you for extremely exciting talk. Everybody in the audience were captivatingly listening to you. Landing at Edwards Air Force Base, I have seen the shuttle landing when I was a cadet. And I always felt that if you had a problem, suppose there is for some reason there is problem in Edwards Air Force Base or Florida, Cape Canaveral, is there any alternative airbase or some landing area in the entire world other than those two in the United States where there is a backup for shuttle landing? That was always I was worried about that.
Right, if I understood your question correctly, it was, are there any other landing sites? The answer is yes. When we launch, in the event that we lose some of the engines traveling over the Atlantic Ocean, we can actually land in Morón, Spain. We have potential to land in Morocco, depending upon the orbit. And then if we have to do an emergency deorbit from someplace where we could not get to Florida or California or New Mexico, the United States, we have landing sites, again, in Spain. We have some in Africa. We have some in potentially in Australia that we could go to. So we have a few around the Earth. And worst case is we would fly the space shuttle wherever we could go, and starting at about 30,000 feet, we would jump out and use our parachutes.
Okay. So I have one more curious question that how the space shuttle program, the space shuttle program has been closed by NASA. So do you think that the American space mission is affected in any way by that, or they're of course they're looking for Artemis mission, etc., for new generation things. So you have an opinion because you love space shuttle, you have done a lot of traveling there. Now that the program is closed, do you think that it is affected in any way?
I'm sorry, Senator, it's very hard to hear the question.
No, my question was that the space shuttle program has been closed down by NASA. So do you think that your activities have been affected by that? Space, now that, you used to repair telescopes just like that. Because of space shuttle, you have to repair Hubble telescope so many times. Now that the space telescope program is closed down, is NASA activities affected by that?
So the space shuttle's primary function was to finish the assembly of the International Space Station. Of course, Hubble was also very important. But the principal reason that we stopped flying the space shuttle was once the International Space Station was complete. Now we go to the station using a SpaceX capsule or a Russian Soyuz, and soon, hopefully, another capsule. Who knows, perhaps someday, because I keep reading about India's efforts for a human vehicle, maybe we can fly in that. But for the Hubble Space Telescope, we don't have a vehicle that can go there right now. But I'm hoping that maybe in the next 5 years, there will be the capability with one of these other spaceships to go back, maybe even with just a robot, to upgrade and repair the Hubble one more time.
Okay, do you want to talk to your colleague too?
Well, I'm really fascinated by the details which John has shared with the audience. And I would have loved to have a one-on-one session with him to ask some questions which relate to crew coordination and the challenges as he sees in the coming years as space exploration moves forward and our civilization gets ready to colonize first the moon and later the other planets, and what in his view would be the adjustments that will have to be made. So perhaps we could leave that when we meet at one of the Association of Space Explorers annual functions, John, and I hope to meet with you there. And thank you very much. It was a fascinating presentation. Thank you.
But if you see that, thank you very much, John.